Hi, this is lesson 1.6, which is about composition of functions and actually working with different math operations with functions. So we have a warm-up where you're imagining a situation where you're buying a pair of shoes for that should have been $160, but you've got two different ways of getting some money off that. You want to know, one of them is there's a sale where they're taking 50% off as a discount, and you also have a voucher that would take 20% off the price. So I want you to work out and see whether it matters, whether you take off 20% off and then take the 50% off, or whether if you take 50% off and then take $20 off that. So work out the two amounts you'd pay depending which order you do them in, and come back to me in 3, 2, 1. So let's pretend these are two, let's call these two functions. Let's give ourselves in blue, we'll have a blue function where we take $20 off. So that's, say, your function of x here, the amount you're going to pay is going to be the amount the shoes should have been, take away $20, okay? And we're going to have another function where the amount you pay, we'll call this one g of x, where the amount you pay is the original price of the shoes and you're paying 50% of it, so it's going to be half the original price. So what we would have here, the amount you're going to pay, if we take off the $20, then take 50% off that, we would have $160, which we take $20 off, which gives us $140. And then we're going to put the 50% off that. So the final amount we're going to pay is going to be $140 divided in 2, which is $70. So that's how much we pay on scenario A. We're paying $70. Okay, let's have a look at this one. The first thing we're going to do this time is take 50% off. So we're starting at $160. We're dividing it in 2, so we're paying $80. And then we take $20 off that. So we've got $80, take away 20, and we're only paying $60. So it made a huge difference. It's much, much better if we do it this way around. Okay? What we're looking at here is if we have these two functions, the first situation, I don't know if you can remember this, the first situation we were doing was we were doing g of f of x, and our answer to that was $70. So this is composition of functions. We are taking 50% of the cost, taking away $20. We do this part, the inside first, then we do what's on the outside. And if we did it the other way around, if we finished off with f, taking $20 off, and the first thing we did was take 50% of our costs, we ended up only paying $60. What we've just shown here, I think you should remember this from Algebra 2, is called composition of functions. And if you change the order in which you do certain math operations, you're going to get a very different answer. So there's one way of writing this. This is the composition f, how you say that, f of g of x. X is your input. It's going into, it's like you've got x, it's going into some function called g of x. What comes out of g of x, so it goes into this and g of x changes it into something else. Then it goes into your second function, which is the one on the outside here, and then out comes your final output. Okay, so yeah, x goes into g of x, what comes out of g of x goes into f of x, and you get your final output. And what we've just proven is that f of g of x is often not the same as g of f of x. The order in which you do this composition matters. Okay, moving on. So here was your warm-up, nicely written out, not with my mouse. So let's have a go at these. Oh, then there's the other thing to remember. This is not a dot. This is not multiplication. This is another way of writing f of g of x. It's sort of easier to understand if you write it this way, but often in textbooks it's written this way. This is f of g of x. This is f of g of x. This is g of f of x. This is g of f of x. So let's have a look at, we'll do questions 8 and 11 for short now. This is saying f of g of x. So I think I've got this all nicely written. Let's just try. Yeah? This is saying f of g. F is on the outside, on the inside is g of x. So how we're going to solve this problem is we're going to write out f of x, but where there's this x, the placeholder for the input, in its place, we're going to put g of x, which equals 4x plus 1. So we're going to write this. Here is f of some input squared minus 3. What's our input? It's g of x. What can I write for g of x? I can write 4x plus 1. So order of operations, what I have to do here is square 4x plus 1. If you want to pause your video and do it on your own, you're welcome to. 4x plus 1 squared would be 4x times 4x would be 16x squared. You'd have your outer and your inner would both give you plus 4x plus 4x. So you'd have plus 8x. And at the end, you've got plus 1. This is supposed to be a 3, nastily written. Next step, distribute that 2 to everything. Oopsie. And you'd have 32x squared plus 16x. This gives you plus 2, and you're taking away 3, so you end up with this. Okay, so you could try g of f of x and g of x following the same idea. They're easier than this one, ever so slightly. Let me go over number 11 for you. What's this question saying? Our input this time isn't just x, it's the number 3. Which of these is 3 going into? This is f of g of 3. So it's f of g of 3. Okay, the 3 is going into g, and what comes out of that is going into f. So let's imagine up here g of x, that x has been replaced with a 3, so that would be replaced by a 3. That would give us g of 3 equals 4 times 3 plus 1, which gives us 13. What we do with the 13, the output of g of 3 is going into f. So this 13 is going to be going into f of x. So here's what f of x looks like. And whatever our input is it's saying up here, our input is going to be g of 3. We've just worked out that g of 3 is 13. That goes in there, so it also goes in there. So we have to work this out. 13 squared is 169. 2 times 169 minus 3. You should eventually get to that as your answer. If you'd like to pause your video and try 9 and 10, and then I'll show you the answers. So this one is g of f of x. So first of all, I write g, and this is what g looks like. G of, what's our input? Our input is f of x. What does f of x looks like? 2x squared minus 3. Now, you see the difference between number 9 and number 11? Number 8, 9, and 10, our input is x. It's algebraic. We're going to end up with an answer with x's in it. Number 11, this was a numeric problem. X wasn't just our input wasn't the letter x. Our input was a number 3. So we were actually able to finish up by actually working out our answer as a number. So on this one, we don't know what x is, so x is going to stay in our answer. We can't get rid of it because we don't know what it is. And we can't combine it with take 3 off it because we don't know what it is. So it's always going to be there in our answer. Distribute the 4 to it. And you've got 8x squared minus 12 plus 1, and then finish that off. Minus 12 plus 1 gives you minus 11. There's your answer on that one. We'll go there. And g of g, you have got here, somewhere hidden, you've got g of x. So you write out g, which looks like that, and what's going inside? Itself. G of x is going in there. So you've got 4x plus 1 as your input. Distribute the 4s. You get 4 times 4x gives you 16x. 4 times plus 1 gives you plus 4 plus 1. These two at the end obviously can be combined. That's your answer on that one. So that was composition of functions. I think we're going to stop there. Let's see our next question. No, why don't you try these two? We won't stop here. Try these two. I'll show you the answer. Be down here somewhere. Be easier if I just did the problem, wouldn't it? Okay. So this is f of g of x. F is on the outside. So we're looking at something squared minus 4. What is our something? What's our input? It's g of x. So this has to go in there. So when you square a square root, don't forget that when you square the square root, that cancels that, and you're just left with this stuff that's in the inside. So this would give us 4 minus x squared for this, still minus 4. So that leaves me with my answer of negative x squared. So that wasn't really example number 12. We're doing this presentation out of order. Okay, function decomposition. That needs to be a new video. Let's stop here.